I'm introducing Mr. Doug Whiteaker. He is the principal in charge at Water Technology Incorporated. Doug Whiteaker has 33 years of experience in the aquatic industry. He's dedicated his career to planning, design, engineering, and construction of aquatic facilities worldwide. Mr. Whiteaker graduated from Luther College with a BA in chemistry and biology. He is currently affiliated with the associations including Construction Specifics Institute, National Park and Rec, and Colorado Park and Rec as well. Mr. Whiteaker is an experienced public speaker, and he has spoken at nearly all of our industry events. I personally have attended at least 5 of his seminars in the past 10 years, and he does a fantastic job. It's my pleasure to humbly introduce an industry celebrity, as Mr. Douglas Whiteaker, to educate us on how design can be and is used to mitigate risk.
Thank you, Troy. Boy, that's quite an introduction. But anyway, this is a really interesting topic, but the theme is water wisdom. And one of the things that's really interesting about that, we all look at aquatics and water through different lenses. Whether you're an operator, you're a programmer, a manufacturer, a designer, a professional that's reviewing plans, or any of the other types of people. And so it's really important that I think. Did everybody attend Byron Embry's discussion this morning? I think one of the neat things he said out of that is swimming is not only a method of drowning prevention. Swimming is an overall method of life enhancement. And that's really so true, because so many people don't use pools as lap swimming and things like that, but they're still swimming. They're still benefiting from all the things that happen in aquatic facilities. What I'm here to do is to share my knowledge of over 33, 38, whatever, however you start counting that, because I've been in this industry for a long time, for aquatic design, how to mitigate the risk of aquatic facility operation and functioning through careful planning and design. And sustainability of aquatic facilities is really based on 3 things: the programs that you provide for a pool. I call it watertainment, but it's the attraction value, the fun that comes in being in a pool. And then also the benefits of the social interactions that you have in an aquatic facility. And so all of these things, are predicated at the beginning of a facility design through the programming and the design teams to meet the owner's missions, goals, and objectives. And so this is a very complex topic. So what I tried to do is simplify it and try to show you what I'm hoping the outcome of today is, that as you are looking at your own facility, as you are looking at plans of future facilities, that you're able to look at what some of the challenges might be for risk management and how you can rectify that. So basically, what are the sources of risk? There's external risk, acts of God. We all know what that legal term means. And then force majeure, where they're chances occurrences, something that had no prediction and you couldn't avoid it, but it happens. But then there's the internal risk, and that risk includes the design, construction, and operations of an aquatic facility. The other thing is the failure to achieve the needed levels of performance. If, like, your lifeguards aren't performing or your maintenance staff doesn't take care of things, so there's a problem. So as designers and operators, what risks are we responsible for? Anybody out there want to chime in? Absolutely. At the end of the day, our clients, our consumers, they want us to be responsible for all of those. Now, what we can do is, the ideal of risk management is minimizes spending, manpower or other financial resources to become, to minimize the negative effects of risk. And this is done through a methodology of identifying, characterizing, and assessing the threats, looking at your facility and understanding where problems might occur. Assess the vulnerability of their specific threats. Determine the risk. How likely is that to happen? Is it going to be something that might happen in just a very odd set of circumstances, or might it happen more often that we need to? And how many people keep track of incident occurrences and where they occur in your facility? That's a huge part of identifying where risks are going to occur, where they do occur, and how you can achieve, and then listening to your clients, your users, especially if you have, I like to call it the active aging adult market, but those people are very, very vocal in where there's issues. Like if they see tile that is sticking up and they're cutting their feet on, or if there's slipperiness on a tile or a deck, they're very happy to tell you about that. And as a good operator, you want to make sure you go over there and take care of those things. So we're always identifying ways to reduce those risks and prioritize those risk reductions with a strategy. And that means if we see an incident report and constantly we have a situation where we're having rescues on a set of stairs or in a lazy river, we've got to find out why and adjust that idea. So this is a really long list, and it's really important because it's really kind of the International Organization for Standardization, ISO, has talked about risk management. It should create value. Resources expended to mitigate risk should be less than the consequences of inaction. And that's a really important statement. I mean, if you really start doing this, looking at how risks are going to occur in your facility, it doesn't really cost you money. It saves you time, effort, and resources. It should be part of your organizational process to make sure that you're identifying wherever risks can come in and how you can adjust that. You really want to go through and address uncertainty and just assumptions, because sometimes you assume things are going to happen, but they might not ever happen. It has to be really systematic and structured so that you can really take care of identifying where those risks are going to be. And it also wants to be continual improvement. All of us have emergency action plans. All of us have, whether it's on our mechanical situations or on our deck or any place where we're operating, we always want to make sure that we're continually improving that. For those of us that have more than one pool, it has to be tailorable. This process needs to be tailorable to, whether we have a 50-meter pool and then a leisure pool, different risks are going to happen at different times at those pools, so it has to be tailorable for that. And the risk management really has to be transparent, and it has to be inclusive of all the things that you're doing. And periodically, you really need to reassess what you're doing to make sure that you're covering all those risks. And so, through the control of the functional characteristics, these are distinguished in three different categories: physical, functional, and operational. And quite frankly, at the beginning, we look at the physical characteristics, and hopefully, we're mitigating the risk in the functional and operational status. And so, let's look at some of these functional characteristics. There's physical characteristics, there's surface properties, there's orientations, adjacencies, mechanical systems, and sanitations. And so this can be a really long, complex list of things to look at, and they must be. When you start designing a new facility, you really want to look through each one of these things when it's going through the programmatic end. But when you're operating a facility, you want to be able to look at each one of these things and find out where risk occurs in each one of these categories. And so physical characteristics, it's primary sensory. It's generally measurable because if you have physical characteristics, you have coefficients of frictions, you have quantitative things you can talk about in terms of hardness, the smoothness, the shape, the control, the volume, the weights, and looking at turnover rates in terms of that nature. You want to define. These are always defined in that programming and concept design phase. You want to, and they're finalized in that documentation and implementation phases when the facility's constructed, and then as an operator, we are faced with all those things when we're turned over the keys, and here it is for a fun and exciting place for our patrons to enjoy. So what I wanted to do is just kind of show you. Now, this is how most of us look at where we initially start looking at risk mitigation, a plan that looks at, okay, here we have a plan of a facility. This happens to be an outdoor. So you want to look at through that, okay, how the entranceways, where people are sitting, how do they access the pools? Is the gateway to the pool closest to the shallowest water? How about the transparency of the facility? Are we going to be able to see through that and look at where we're going to place guards? And we're always looking at that from a risk management, where we're staffing lifeguards. Then we look at the mechanical systems and things over here. What are the turnover rates? How do they meet the state health code requirements? If this is going to be a fun pool, how is it going to be? How are we going to make sure that we're always maintaining pristine water quality, if it's indoor air quality as well? And so those things we have to be able to have a good eye for that. And at the end of this presentation, we're going to go through some examples on plans where we can say, okay, here's a plan. Where are some of the challenges? So here's some images. This kind of shows about a play structure and some guards staffing it, and then the sprays that are coming into the lazy river. Now, one of the things that we have to be very cognizant of is where these sprays are overlapping and where they might cause blind spots in our water, because we're not going to stop having fun and sprays in our facilities. What we have to do is think about this from a staffing perspective so we can see where people might run into problems and they might not be seen when they are having problems. So traffic control. Here's a good illustration of a little kid slide that's coming down here. It has a nice soft landing pad, but it doesn't have any control for people walking past it. So some kid can be coming down the slide, and other people could be walking past it and cause a conflict. This is something we have to watch for. Deck clearances. In this particular facility, you can see just by the design of the ladders and the rail goods, they only have about a foot behind that to get in and out of the pool, have passage by it. That wouldn't fly in most health code reviews, or it shouldn't occur in design. Visual transparencies. You can see with this pool, there's a lot of barriers. So if there are people in the pool, if there were 2 people in the pool, you'd have to have 2 lifeguards. Just because there's just too much obstructed view corridors to be able to see where problems might occur. Some of the interior surface properties, are based by color, slip resistance, abrasiveness, sharp edges we try to avoid, body impact, and tripping hazards. And so this is a deck design. It's a ceramic tile deck. It actually does, include a slip resistant tile. Typically, what we see is a 1x1 or 2x2 ceramic tile provide a good coefficient of friction. But one of the things that's a challenge to this, a lot of owners decide we really want really nice-looking deck drains. They want these little slot drains that are, they look really nice. But how do you clean that? In trying to be able to clean that, if Band-Aids and hairballs and everything else that goes down there, how do you clean that? It's very difficult. So, looking at that early in design and not going for aesthetics, but going for functionality is really important. This shows a non-slip deck, with a broom-finished concrete, and a deck drain that does have the capability of being cleaned. You can lift that up and clean it out, and much easier to operate. Again, having good traffic control, having places where there's safety landing zones, the soft pads that are from these slides. One of the things that we see here is that, from a maintenance perspective, or even from a design perspective, some of the bumpers that were initially installed on that, are now kind of fraying. From a a walk around the facility, we want to be able to make sure that all those things are maintained. Excuse me for a second. Here's an interesting issue on the lazy river. The current is flowing this way and flowing this way. We have a sharp point right there. Those are things that we want to look at in the design or even in the operations, that we don't have these types of things so that people don't are floating around underneath the water, propelled by a current, and run their heads into that sharp corner. Again, this particular facility is actually in. Is anybody from the peninsula or Puget Sound Peninsula? I mean, this is Seattle area. Again, they don't have too many sunny days up there, but this picture was taken on a sunny day, and you can see, even though we have great transparency in this facility, with all the glazing and fenestration in this, there's glare. So it'd be difficult to guard this in some areas. You'd have to have more guards in there. But this does illustrate a nice deck drain that's a non-slip deck, easy to maintain, and the ability to provide a nice functional deck. This is one of the ones with a lot of people in the family aquatic centers going to these run-out slides. There's a mechanical challenge to getting these being able to be on the same level as the pool deck. But this is one solution. I don't particularly think it's a good design solution to be able to raise that up and then have a step coming out of that slide. Because as patrons are coming off the slide, they're excited and they might not see that. Or if they're coming over to see their friends, they might not see that and trip on it. So it's a challenge. Here's a design where the water sprays were placed along the deck side, and so these enterprising young men decided they would make a water feature in the deck. And so, placing these things on common walls and things where they can't, sit on them and spray all over the deck, this creates a water hazard that could be a slip issue, and also wastes a lot of water. Again, I see pools that put these big things, sometimes not so big items, in the floor of the pool. Even though it's a brightly colored object, kids sometimes aren't paying attention, and they could be tripping over these types of things. Now, here's a good example of and this is from the past, where it's a pretty good use of the rails for easy entry of users of all different heights and abilities. But the problem is, look at the closeness of this rail to the column there. It's too close. So from an accessible type of a feature, it becomes a challenge. Again, this kind of shows a very challenging way to try to enter onto that transfer tier, unless you're over here, which doesn't meet the ADA requirements for distance. This is a good example of a facility, again, that has relatively good transparency from this perspective, but the glare on the water becomes very difficult for a lifeguard to be able to see what's going on in other places. Orientation, whether it's a solar orientation, whether it's the lighting levels within the facility, or also the water depth placement. Those are all important aspects to optimize that transparency. This is a facility I visited a couple weeks ago. This is during the day. During the day, that facility had 5-foot candles of lighting on the deck. And at nighttime is even worse. And so the reason for that is because in the original design, they put these lights way up on the ceiling, surrounded them by ductwork. There was no way to get to them. And so they hadn't changed lights in 20 years, which was really interesting. They were talking about having mountaineering guys come in and try to rappel to get them to change lights. I said, well, what you need to do is change light positions and get it so you can change lights. One way that we're seeing that helps balance the light is actually provide clear stories or Kel walls, so you can bring natural light in all over the facility so you don't have glare. It's a diffuse light. This is a good example of how that can occur and have natural light that doesn't create glare. This is an image of a pace clock that had too long of a cord, so it was just laying down here on the deck. And so that became a tripping hazard. And, of course, curious kids on this particular pool might also find that kind of fun to play with in an inappropriate situation. Again, glare, across the pool is very important. Here's a good image of a nice pool. It's a wave pool. Obviously, there's nobody in it this particular day. It was raining, but it does show, having lots of play facilities in this. There's great transparency, even though it's a wave pool. It can be guarded with minimal staff, but yet when this pool's busy, you don't have to worry about people not being able to see all around the pool. Here's a particular pool that we're seeing a lot more of, the splash pads. The splash pads oftentimes are one of those anomalies. Do we need to guard a pool that's only 6 inches of water depth? Well, I think we do, and it's really important. But one of the things that all of us in the aquatic design industry are doing is challenging the manufacturers to make it more transparent. Because if there was 2 kids in this pool, you need 2 guards to be able to see it. And then when you start to get 150 kids in this splash pad, you need to have even more. Overhead clearances, how these are designed, there should be a fence around this so people can't bump their head. You can see the operators have been kind of creative with taking noodles and slicing them in half and putting them on the stair rail. But again, that doesn't prevent somebody from banging their head into it. So it's really important to look for that in the design of these facilities. This is a good example of what happens when you don't have a sufficient interior light and you have a lot of exterior light, and you get dim light levels over here, and then it creates that glare. So that's why it's important to bring in, if you're going to use natural light in a facility, to bring it in as diffuse light and bring it in as deep into the facility as possible so you have even light levels around there. This is an example of a facility. This particular one, again, has those deck sprays, which really should be over here, so they're not causing possible water loss. But again, this illustrates a pretty good transparency, so you can see through there. That's by design, and that's one of the things that we're seeing. Even the play structure, you can see over here, you can see underneath the play structure, so that you have that great transparency. The adjacencies, this is another good place where we mitigate risk. Where are different components, like lazy rivers? Where's the shallow end? Where's the entrance to the locker rooms placed? Where are the lifeguards' positions? And, where are the amenities? So that we can design a facility that has good entertainment value or watertainment, but also is easy to guard and maintains its programmability. This one shows the facility that some of the challenges here. It does have good transparency, except for right here in this play structure. But one of the things that are a challenge here is that they had a guardrail here, but this is 10 feet deep water, and this is zero depth entry. And so guess what? That adjacency of shallow water to really deep water created a lot of risk and hazards by people coming, little kids getting into that area and causing risk to happen. This shows a very transparent facility. Again, this is zero depth water, though, right next to a lazy river. And so what they did, instead of putting a screen there, they placed a position to guard to make sure that this challenge of having moving water right here next to this zero depth water didn't create an issue. The other thing that this pool does have, this over in this room, is their competitive pool. So they actually separated their competition pool from their leisure water. And they have a common entrance over on this side, so you can either go to the competition pool or go to the leisure pool, which works out very nicely, so you can have swimming meets while you're still maintaining your leisure and warm water activities. This is another common occurrence that we see, that where people come in, this is a 1-by-1 tile. It was well maintained in the fact that the night staff came in and every night buffed that tile. And they did a really good job of keeping it clean, But what they did is made it really slippery. And so, using the proper cleaning chemicals so that you don't shine the tile, you keep its coefficient of friction. And this is what people have had to do to, put different types of mats down so people don't slip. And again, you can see this is a wall here. There's a nice plant, and this distance between the ladder and the wall is very close. This is a good example of having transparency in your design. This is a nice leisure center. It does have 2 water slides on it, but those water slides actually, for the most part, exit the building, so you don't have all the clutter of the water slides indoors, and so it's relatively transparent. The problem is the lifeguard that's up here can't see the exit of the flumes, and so they have to have a red light, green light system. They have to have extra guards to be able to operate that correctly. This is a facility that, again, has a really nice ramp that offers accessibility to the pool. It's very heavily used by a lot of different programs, including lap swimming. But again, look at the glare that's occurring because of the exterior windows. This is a great example of spray interference. This was prior to putting in a rescue profile. Now you can see that rescue profile, and you have to really look for that to see that underneath the water there. And that's only 18 inches of water. Here it is in a lazy river where you can't see that rescue profile underneath the water. And so it's really important we were taking a picture of that, and so it's really important to consider how sprays are going to combine so that you can make sure you can see through those on the design. Mechanical systems are another place where, through design, we always look at turnover rates. Sometimes some of our state health codes are, they're the minimums. We have to remember that. The guidelines are the minimums. And if we're going to do a pool that's going to be more heavily loaded, have a lot more people that come to it, we've got to exceed those and have faster turnover rates and make sure that we're doing everything, because some of these health codes were authored in the 70s when we didn't have leisure pools and some of the spray pads and things we're doing nowadays. So in design, we've got to look at that. So we've got to look at turnover rates. We've got to look at the type of filtrations, how we're collecting and distributing the different water, and then make sure that it's easy to operate because a lot of times some of our operators, it's tough to get great help these days and maintain them. And so we want to make sure we're designing for the level of our staff. Otherwise, if we get it too complicated, there's not too many mechanical engineers that are operating these swimming pools. Some of the trends that we're seeing in the industry to try to help provide crystal clear water that's easy to maintain and cost effective is using regenerative media filters. Regenerative media filters really operate to a lower micron size. We're seeing the popularity of the medium pressure UV systems going in on every body of water in these, especially these leisure pools indoors, and also even on the booster pumps that we're atomizing the water to be able to take the chloramines and the byproducts of disinfection out of those facilities. This is some examples of what not to do. I mean, this is the lifeguard safety room. You can imagine what would happen if there was a rescue that had to take place in this particular facility. I don't know how you'd get to the cot. Again, this is a different facility. This is the pool manager's office. I don't know how they would operate. So, I mean, if I was a consumer and I walked into this facility, I would turn and walk out the door if I saw this, because what kind of level of competency does this kind of tell you is happening here? And this is the look from the entrance through the facility. I mean, it's just this was even a funnier thing. They had a an HVAC unit on top of this, and they had open guard rooms, and they're constantly sending up guards to flip the switch on the HVAC unit, and they had open locker rooms right next to it. It's like, I don't know if I'd want to change in that room. So you see a lot, but so through design, we want to do is take care of a lot of these issues. Here's some of the things we see in chemical storage rooms. Again, where things have been stored there for such a long time, they don't even know what it is anymore. Broken bags, just a complete biohazard waiting to happen. Here's chemicals that have been stored in a facility. We've got acid, we've got chlorine, we've got hydrogen peroxide. We have a whole bunch of different things in the same chemical storage room that wasn't ventilated. And again, this is a potpourri of things that shouldn't be all in the same place at the same time. And so it's really important to look at all these designs. Mechanical rooms, by design, shouldn't be mechanical closets. We should have accessibility to be able to change out pump motors, to be able to move valves and get through here, not become storage rooms for other things that are happening. Again, you should not have to be a contortionist to be able to change a pump motor, or even to look at the pump strainer basket to be able to see if it needs to be changed. If you design in a situation where you don't provide good access to it, guess what? Today's operator is not going to look at it until there's an issue. Again, another potpourri of things happening here. You can't get to any of the pumps. We've got chlorine being stored there right next to everything. So that's just an accident waiting to happen. And so we want to make sure that every time we look at these facilities, we're designing in enough space to properly store and maintain and operate all the mechanical systems. Here we have a great situation where we're storing dry chlorine, acid, and liquid chlorine all in the same spot. We have chemical pumps that are having their lines, no conduits around them. So guess what? What happens if the liquid chlorine and the acid decide to kind of start leaking at the same time? That would be a very nice response. And again, this was even open to the pool area. Again, here's a mechanical room that had a little bit more room, but through design, it wasn't really thought out where the valves need to be in the surge tank. So they just kind of put them wherever they wanted to be. And so now it becomes difficult to access all the filtration systems. This is one of my things I always look for is indirect connections. This is actually a filter that's backwashing at a high rate as a direct connection to their sanitary sewer. And the only thing that saves them is that it goes into a much larger sanitary system. If this was tied into a smaller sanitary system, whenever they backwash their filters, they'd be flooding basements throughout the neighborhood. Again, I don't know if I'd want to adjust this chemical controller with all the wires and things that are open, a junction box that isn't been maintained. So these are the types of things as an operator we need to look at from a design, how we control this, and every single day we should do an audit. We should have a checklist of different things that we need to make sure that we're paying attention to so our facility doesn't get to this level, and that creates a challenge. Again, here's a much better laid out mechanical room, except for, now we have acid and chlorine right next to each other, in the same space with all the other mechanical equipment, no chemical storage rooms that are separately stored and ventilated. And again, these poly tubes don't have any conduits around them, so anytime a little leak occurs on that, you can walk into a nice acid bath if you'd like. Again, this is some of the things we see on these mechanical rooms that have become mechanical closets, and they start stacking things on top of each other, and so the operator's not going to maintain it. So these are things we have to look at. This picture kind of illustrated putting metering pumps inside the chemical storage rooms. Well, even though the chemical storage rooms are ventilated, they're still exposing these chemical storage pumps. The manufacturers love to put these in here, but these should actually be outside of it, so that they're in an area that's easier to maintain. Again, chemical storage pumps right over the chemical storage vats. These actually have a sacrificial bung that has a small line in it so that it's not off-gassing into the room, but there's no vent. So they were wondering how come they can't get stuff out of their tanks, even though their tanks are full. This is an example of a relatively well laid out room. You know, there's plenty of room to get around all the pieces of equipment. Nothing's in their way, and so it does provide accessibility and ease of maintenance. Again, some of these rooms get pretty complicated, but again, this particular room, even though there's a plethora of piping and all the things that are happening here, everything is easily accessible, and you can walk through it without the fear of snagging your clothes or having a disaster happen. This is an example of a well, thought out, testing area. All their pool's controllers are here. They have a sink. They have a storage area for all their records, and it's nothing fancy, but it's one of the things that makes a pool operation much easier and well thought out, and everything's in its place. One of the things we look at on competitive pools. Now, how many people should it take to move a bulkhead? We have a girls' swim team. Half of them are over here, and half of them are on the other side trying to move that. Well, that's something we have to think about in design, so we can easily move those bulkheads and not make it a challenge or worse yet, an injury for the athletes that are coming to practice in this facility. So here's kind of some of the things we look at from design. We look at this facility. This is what a lot of people see as their first entrance into their new facility. What are some of the issues with this? Yes, sir.
Well, I've seen a lot of mix of different activities. So like a lap pool, and then there's looks like a shallow pool, a kiddie pool down there.
This is actually a whirlpool or a spa. Well, the things that I see as challenges here, we've got this big play structure right in the middle of the pool. That's going to not be good for transparency. The second thing is, now this is in one of those states that allows underwater steps where they go from 2 feet of water down to 3.5 feet. Well, that can be done safely, but it should not be done when it's right next to the lazy river, because there's eddies and currents that are occurring when you have a lazy river next to that, and so that's a challenge. And then the water spray right here is going to obscure your vision. So I've kind of circled what those areas might be. Here's a pool that probably is a better example. There's a play structure here, but it does have transparency. There is, still another one of those little sprays here that needs to be addressed, and it could be an issue. And so but the slide's kind of off. So the other thing that's good about this design is that you enter in from, this is kind of their family locker room changing area, men's and women's locker rooms. And so you do enter into this facility from the locker rooms on the zero depth entry of the pool, which is a desirable approach. Here's a much more complicated facility. So basically, what we see here in this particular facility, this is a raised area. This is the competition pool and the leisure pools all in the same room. And so here are some of the areas that we want to look at. The wave action, how it's going to interface that, the drop off here. Here's another facility that the leisure pool and the competition pool are separated. One of the challenges is here's the locker rooms right here. So the locker rooms enter into this deeper water, so there's been a lot of rescues right here. There's a slide that's in the middle, so it's hard to see, and the slopes on this pool are kind of funny. And so basically that's kind of a quick look at, and I hope what this conversation has done is help you look at it from a plan view, look at some of the things that are places that risk occur so that we can help in the design phase be able to mitigate these risks. So when the pool is put into operations, when it's really full of people enjoying it, from programs, the watertainment and the social aspects of it, that your pool is easy to operate and it's safe to maintain. Any questions or discussion? Yes, sir.
For lighting, how many foot candles are you looking for? When we've had plans come in, there's been discussion about, like, we've asked for certain foot candles up off the deck, and they're saying, oh, we're going to get dazzle. Or
So can you repeat the question one more time? I'm sorry.
so what sort of, how many foot candles are you looking for in a pool, interior or exterior?
The question is, how many foot candles are you looking for in a pool, interior or exterior?
Well, the first place to look is in the state health department's guidelines and see how they address the topic. But oftentimes, just kind of some cursory lighting levels that we would see. I would say you would never want to have under 35-foot candles in a leisure pool for nighttime use. Oftentimes, it's between 30 to 50-foot candles across the decks and the pool area inside of a leisure pool. Now, when you look at competition pools, there are very specific requirements, both on, from FINA, USA Swimming, NC2A, and all those. And so at the end of the day, they give you very specific lighting level requirements based on whether you're training or you're going to have competitions in that pool. And some of the qualifications for having training is like 35 to 50, and then you want to have about 100 when you're going to actually have competitions in that pool that might be televised. Or even at high-end events, it's going to be closer to 200 to 300-foot candles when they have international competitions.
So that's across the deck?
Across the deck and the pools. Anybody? Yes, sir.
The question is, as a designer, when do you feel the operators or facilities themselves are going to get involved in the design process?
I think the operational staff and managers of a facility should be involved from day one. They should be there at the beginning. They should have ownership of the design, and they have their programmatic needs. I mean, design should start with a spreadsheet. I mean, a lot of designers want to start out with great-looking images and things like that, but design should start out with a spreadsheet, first to find out what size you need to meet all your programmatic and recreational needs. Then that'll tell you how many square feet you need, and then based on the programmatic, you should then start on that same spreadsheet, understand when you have programs, how many users you're going to have for your Learn to Swim programs, for your competitive swimming and different time schedules. Much like Sean's presentation beforehand showed how many, how the pool is being utilized. You should do that before you start coming up with any design. And then you should start coming up with the design, giving the correct adjacencies and clearances. So to answer your question, the owner's personnel from an management and operational staff should be involved in the entire process to get it from a spreadsheet to a design and be able to look at some of the challenges that might occur. Any other questions? Yes, sir.
You might not be able to answer this one. How do you convince architects you need more room in a filter room? I just did a layout for renovation, and they wanted to reuse existing equipment. So I made the design cleaner, submitted it to the architect. By the time I got the plan back, they'd taken off 6 feet of the room for a lifeguard room, put in an oil storage tank, and another door. Now, the door was good for access, but now I'm running chemical lines up over a door, okay, to get from chemical area to filters. Do you use mitigation risk?
The question is, how do we convince architects to make the pump rooms a little bit larger, and what takes priority? Is it the pump room or other pieces in the puzzle of the architecture?
The answer is it's not an easy task, but again, going back to this gentleman's question about when do you involve the owner and their operational staff, that it is their building. They're going to be responsible for operating that building and maintaining it safely. And so what we do is we tell the architect, we can't tell you what the size of the mechanical room is until we understand what the size of the pool and all the equipment. And that's oftentimes not into the way into schematic design, almost in the beginning of design development stages of a project. And so we have records of what it should be based on the components that are going to be in there, so we can give you square footage. But it's really important to really get the architect to understand that you're the professional, you're helping design this mechanical room so that it's laid out safely with correct chemical storage rooms, correct clearances around there. And if the architect doesn't want to listen because they're trying to squeeze it into a mechanical closet, you got to get the owner involved. And when the owner's involved, they'll help you see through that. And oftentimes, the health department officials are going to also have a say in it. There's a lot of health codes in the country have requirements for how much clearance has to be around equipment. So you can't put too much equipment in a room that doesn't have the clearances. Otherwise, you're going to provide you're going to be in the next image.
All right. Yeah. So I think you have one more time for one more.
Yeah, Doug, comment on your discussion you just had, getting the owners and the operators involved. Amen.
I don't think I need to comment on that.
Yeah.
No comment on that. Most architects don't do it. So architects, engineers don't involve the owners. They create the plan, and here it is, this is what you're going to do. And I don't personally feel that that's wrong.
That is a recipe for a less successful facility than it could be if there was correct collaboration with all the people involved. And it's not just the maintenance guy, and it's just not the programmers, it's just not the managers, it's the whole team. Bringing that whole team together in a collective effort to achieve the success for a facility, and that's what's going to happen. So I want to thank you very much for coming. It was a pleasure to be in front of you guys today, and a lot of great ideas coming out through here, and just enjoy the rest of this conference, because this is truly, and as you guys have all known this, it's truly one of the unique conferences in the world where people come together, share ideas in a very professional manner, and even new ideas to help make all of our lives and our clients' lives easier. So thank you very much.
Thank you, Doug.